Welcome to the Explainer. So today we're going to talk about two pieces of tech that have, and I mean this, completely changed the game for building software, Docker and Kubernetes. We're going to follow the journey of your code, right? From just a little file on your laptop all the way up to this massive, powerful application living out in the cloud. So here's how we'll break it down. It's actually a pretty cool story. We'll start with a problem every developer knows all too well. Then we'll look at the first brilliant solution, Docker. But that solution creates a new problem, right? A problem of scale. And that's where we'll bring in the final piece of the puzzle, the big boss, Kubernetes. All right, let's get right into it. We're going to kick things off with a problem that is, well, it's so common, it's pretty much a rite of passage for anyone who writes code. Have you ever said this, but it works on my machine? Oh, man, those 5 little words, they're infamous for a reason. And it's not just a funny meme, you know? It's the core of a massive headache we call the deployment dilemma. Your app is flawless on your computer, but then you try to run it somewhere else, a test server, the actual live production environment, and boom, it just breaks. It's super frustrating, wastes so much time, and it happens all the time. So what's the deal? Why does this happen? Well, the core problem is what we call environment inconsistency. It's all these tiny little differences between places. Maybe your laptop has version 1.2 of a library, but the server has 1.3. Or maybe you're on a Mac and the server is Linux. It could even be some tiny configuration setting you've never even thought about. Each one of these little differences is like a hidden landmine, just waiting to blow up your deployment. So, okay, how do we get out of this mess? Well, this leads us to our first big idea, the first part of the solution, and it's an absolute game changer called Docker. The genius of Docker is this thing called a container. And honestly, the best way to think about it is like a real-life shipping container. You know, the ones on boats, but for software. It takes your application code, and then it packs in everything else it needs to run. All the libraries, the right system tools, the specific settings, the whole shebang. It all gets bundled together into one standard, self-contained, totally predictable box. Okay, now this is where things get really cool. Let's compare these containers to the old way of doing things, with virtual machines, or VMs. The key difference, and this is really the secret sauce, is that containers share the host operating system's kernel. They don't need to boot up a whole separate operating system inside them. And what does that mean? It means they are unbelievably lightweight. We're talking megabytes, not gigabytes. And they start up in seconds, not the minutes it takes to boot a full VM. It's a huge difference. And this is the workflow it gives you, and it's so beautifully simple. First, you build your container image using a kind of recipe called a Docker file. Then you ship that finished image up to a shared library like Docker Hub. And from there, anyone can run that exact image on any computer that has Docker installed. That whole "it works on my machine" problem, gone. It's replaced with "it works everywhere," period. All right, so Docker is amazing, right? It totally solves our consistency problem. We've got our neat little software boxes. But as often happens in tech, solving one problem can create a whole new one, especially when you start to think about running things at a much bigger scale. Think about it. A real application isn't just one lonely container. It's probably a whole fleet of them. You might have a container for your website, another for your database, another for user authentication, maybe dozens or even hundreds of them, all needing to work together. So now the question becomes, how do you manage all of that? How do you deploy them all? How do you handle networking between them? What happens when you get a huge traffic spike and need more of them? And what if one of them crashes? You can't just be sitting there manually trying to fix everything. It's just not possible. And this is where we get to the next big idea, container orchestration. It's a fancy term, but all it really means is automating the management of all those containers. We're talking about automating the deployment, the scaling, the healing if something breaks, basically taking the human out of the loop to manage this massive fleet. Yeah, I really like this way of thinking about it. An orchestrator is like the conductor of an orchestra. You don't tell each musician what to do. You just tell the conductor, I want the music to sound like this. Same idea here. You tell the orchestrator, hey, I need 5 copies of my web server running, and it just makes it happen. It finds the computers with enough space, starts the containers, and then it just watches them 24/7 to make sure your wish is always its command. So, if we need an orchestrator, which one do we use? Well, in the world of container orchestration, there is one name that stands above all the rest. It's the industry standard, the one that powers just about every major tech company you can think of, and it's an open source project called Kubernetes. Kubernetes, or K8s for short because Kubernetes has 8 letters between the K and the S, get it? Is that grand conductor we were talking about. It's the brain that manages all of our Docker containers and lets us run them reliably, even at a crazy scale. So let's just quickly look at a few of the basic ideas inside Kubernetes. Okay, first concept, the pod. You can't get any more basic than this in Kubernetes. It's the smallest thing that Kubernetes works with. And a pod is essentially just a wrapper around one or more of our Docker containers. It's like the basic building block, the atom of the Kubernetes world. Now, here's the thing about pods. They can come and go. Kubernetes might destroy one and create a new one to replace it. This means their network address, their IP address, is always changing. That's a problem, right? So to fix that, we have something called a service. A service gives a group of pods one single, stable network name and address. It's like a permanent front door for your app, no matter what's happening with the pods behind it. And the last piece for today is the deployment. This is where the magic really happens. A deployment is where you tell Kubernetes what you want the world to look like. You say, I desire to have 3 copies of my web server pod running. And the deployment's job is to make that happen. It will create them, monitor them, and if one dies, it'll replace it. It also handles cool stuff like updating your application to a new version, one pod at a time, so you have 0 downtime. It's incredibly powerful. Of course, just using this stuff isn't enough. To run it well in a real production environment, you have to be smart about it. There are some key best practices that are just not optional. Things like using namespaces to keep things tidy, setting resource limits so one app doesn't hog all the power, using health checks so Kubernetes knows if your app is actually working or just pretending to, and, of course, locking everything down with proper security. So, let's zoom out and put it all together. Why does this matter? Well, Docker and Kubernetes are this amazing 1-2 punch. Docker gives you consistency. Your app runs the same everywhere. And it gives you portability. You can run that container anywhere. Then Kubernetes comes in over the top and gives you the intelligence and automation you need for insane scalability and self-healing resilience. They're a perfect match. Look, these two technologies together, they didn't just change the rules of the game. They invented a whole new game. They're the foundation for how modern software is built and run in the cloud today, which really just leaves one final question for you to think about. How could you use this combo of perfect packaging and intelligent orchestration to completely transform your next project?